This video lecture deals with the content of Chapter 2, which in turn deals with, in part, linear horizontal motion. Linear horizontal motion is motion on a straight line, that line being horizontal. I show such a line here. We refer to it as the x-axis. On the x-axis there is placed a reference mark labeled 0. There are tick marks to the right, which correspond to positive x coordinates, and marks to the left, negative x coordinates. In all of our studies of, except in one case, of motion of object along a straight line, we will imagine that wherever the object was when we began looking at it, or imagine that we began our observation period, that's what is the 0 reference mark on the x-axis. Later, at the end of our observation period, the object will be at some other x coordinate, and we label that x coordinate x. The amount of time it takes for this event to occur, called a displacement, is symbolized as t. Time t is measured in standard units, which are seconds. Locations along the x-axis, a distance location measured in meters, again a standard unit in physics. We define a quantity called the average velocity, symbolized v with a bar on top of it. It's the ratio of the displacement that occurs during some time period t, divided by the time period t. A more common form of this relationship is shown here in the red cloud. Rearrange this equation and we have that the displacement of an object is equal to its average velocity times the time period in question. An example of a calculation of the average velocity is shown here, where during some time period lasting 3 seconds, the displacement of our object is 18 meters. That means that when we began our observation period, the object was at the 0 mark on the x-axis, and later, 3 seconds later, it's at the 18-meter mark. Well, you divide the two quantities according to this ratio equation. You get 18 meters divided by 3 seconds. I need to point out that the abbreviation of the word meter is m, not to be confused with a later quantity called mass. And the abbreviation of the unit second is, of course, s. Final result is 6, and the units are m/s, or meters per second. So now we know that the standard units for average velocity are meters per second. It represents the number of meters of travel that occur each second, the increment in the distance away from the 0 mark that's achieved each second. In this case, you're 6 meters farther from the origin or reference mark than you were 1 second earlier. Now we turn our attention upstairs to these quantities, v0 and v unsubscripted. v0 represents the initial velocity of our object. That's the velocity the object has when we first looked at it, when we first observed its motion. That's when the object was at the 0 mark on the x-axis. Unsubscripted v is the velocity the object has later when it's at a different place on the x-axis, at a place symbolized as x. Velocities represent the gain, and it could be a loss, in the distance from the reference mark. So, for example, if the velocity of an object is 5 meters per second, that means with each passing second it's 5 meters farther from the 0 reference mark than it was before, 1 second earlier. We speak of the average velocity of our object once again. We already did once, and we learned how to calculate the average velocity using this equation. There's a second way to find the average velocity of a moving object. I call it the middle value rule. What you do is add the beginning velocity, v0, to the later velocity, unsubscripted v, and divide by 2. Let's put to use these two equations in the clouds to solve a simple problem involving the motion of an object. Suppose during a 4-second time period, the velocity of our object changed from 30 meters per second to 70 meters per second. We ask the question, what was the displacement of our object during that time period? What was x? Well, we saw earlier that x is v bar t. V bar, according to this equation, is 1/2 the sum of 30 and 70. Half of 30 plus 70 is 50 times 4. Final result, 200 meters is the displacement of our object. Velocities of objects that are moving may be changing. If they are changing, we say that the object is accelerating. An accelerating object might be experiencing an increase in the velocity with each passing second, or a decrease. We use the word acceleration in both cases, a speeding up or slowing down. Well, this is the equation that allows you to know what the velocity will be at some later time t, given the initial velocity and the acceleration. Give you an example. Suppose that each passing second there's a gain of 2 meters per second in the velocity. That means that the acceleration is 2 meters per second, in the parentheses, per second. Written this way, 2 meters per second squared. So now let's take this value of a and a presumed initial velocity of 6 meters per second to predict what will be the velocity later after 5 seconds have gone by. Substituting 6 for v naught, and 2 for a, and 5 for t. Final result is 6 plus 10, or 16 meters per second. I'll have more to say about linear horizontal motion in video lecture number 2.